Hey everyone, welcome back to another lab walkthrough video. This week we're going to be looking into the case of the mysterious geese death. So background info gives you the scenario. A bunch of geese in Canada just randomly appear dead. Our job is to figure out why. So you have a prediction based on the reading and your knowledge of science. There is also a hint. Think about what makes the river different from the lake. Again, if you need to go back, read that paragraph again, by all means do that. I got some more background info on what electrolytes are because those are important. So let's start the lab.
Okay, so our goal is to figure out why these geese are dying. So what you're going to need at your station is a 150 milliliter beaker, a stirring rod, and some salt. If you're running low on salt, you can grab it from your teacher's desk. We'll also have a conductivity meter. Now these conductivity meters are fragile, so please be careful with them. So the first thing you're going to want to do is go up to the teacher's desk and get distilled water. It will be in a big bucket like this. You want 125 mils. It doesn't have to be exact, but something close. So scoop it out. That's pretty perfect. That's it. Go back to your table. So then when you have that done, you're going to test the conductivity of the water alone. So to test your conductivity meter, make sure this switch is locked in place, touching the springs in there, so you have that metal contact. And you're gonna want to touch the ends together. If the light turns on, which this one is doing, just like that, your conductivity meter is working. That means the electrons can travel through. So you're gonna want to test whether or not pure water conducts electricity. So you're gonna put the two ends into the water, and as you can see, nothing happens. So the light bulb should not turn on, that's expected. If you get a very faint glow, that's just because it's contamination from previous classes. Next thing you're gonna wanna do is open up one of the salt packets, pour it into your hand. The first thing you wanna do is test a pinch of salt. So here's the whole packet. Take a pinch, sprinkle that into the water, give it a nice stir, and let's test the conductivity of it. So again, put the ends in. And if you can't tell in the video, there's a very faint glow to the light bulb. Let's see if I can maneuver this so you can see it. There is, when they're in there, a faint glow. So nothing, faint glow. Then we're going to add the rest of that packet. So now this is one packet of salt added. Give it a little stir, help that salt dissociate, and then you're going to test it again. And now you can see the light bulb is a little brighter this time around. Again, I can show you this. Here we are. That should be brighter than what it was with just a sprinkle. And your last test is going to add 2 packets. So take the second packet, rip it open, pour all of it directly into your beaker, give it a stir, and test it again. And here we have the brightest light that we've had so far. So super bright light with the most amount of salt added. So that's it. You've collected all of your data. Now at this point, you're going to clean up. So cleanup involves turning this off. So popping that back out. And again, don't worry, you're not going to electrocute yourself with this, even if you're putting it in water. All of your little salt packets, they get thrown out into the garbage. Your beaker with salt water, dump that down the drain, give it a quick rinse, and you're good to go.
So all of your data goes into this data table, and again, your observations are how bright the conductivity meter was, if it even lit up at all. Again, before you move on, make sure you are cleaning up. And then the questions at the end, you're ranking the different solutions one being the least conductive, so either the light bulb doesn't turn on or it's the dimmest, to four, the most conductive or the most brightest bulb. Then you have a few other questions that talk about the relationship between ion concentration and conductivity, and then circling back to why we think these geese have died. And that's it. Hopefully you solve the case.